In our second part of lesson 66 today, we'll be talking about our phase shifts and also our period changes with regard to our sine and our cosine graphs. Now, in previous lessons, we've done just phase shifts, we've done just period changes. Now we're going to put the two of them together to get one big equation for our final answer. So just to go over a couple of things, first of all, starting off with the period change. Remember, the period is the rotation, how fast is the graph moving. I'm going to use my sine graph as my main example, and the same thing will be true for cosine as well. If you look at this equation where it says y equals sine theta, that was our very basic sine graph that we had. Well, where did sine graph start to repeat itself at 360 degrees, at one complete rotation around the Cartesian plane? As we saw when we talk about our period changes, as I put a coefficient into the question like 2 theta, it made the graph rotate either faster or slower. Well, what does this mean when it says y equals sine 2 theta? The graph is rotating twice as fast. So by the time it's hit 360 degrees, it's already rotated twice. So therefore, what is the new period? What is the new rotation for this graph? It is 180 degrees. So 360 divided by 2 gave me that 180. Same idea if I showed you y is equal to 3 theta. What is the normal rotation? 360 degrees. So when it says 3 theta, the graph has already rotated 3 times before it hits 360 degrees. That means the period is going to be 120 degrees for 360 divided by 3. Just going through one more example. If it says sine theta over 2, well, that's the same thing as me saying sine 1/2 theta. The graph is going half as fast. So by the time it's reached 360 degrees, it's only done half of the rotation. Therefore, the new period has to be 720 degrees. It's like 360 divided by a half, and dividing by a half is the same thing as multiplying by 2. So 360 times 2 gave me 720 degrees. Now, one thing we do want to be careful of as we're writing our equations today is going to be dealing with the argument that we have with our trig function. The argument is what you have behind the sine or the cosine. It's always going to be easier to write and then to understand the argument if it's written in factored format, and I'll show you that on my next example here. If I were to give you this question and it said y equals sine parenthesis 2 theta minus 90, the number in front of the theta gave us the rotation or the period change, and the number that was behind the plus or the minus gave us the phase shift or the angle that it moved to the right or to the left at. Well, having the number inside the parenthesis with that number 2 there, it affects the entire question, because this makes it look like the phase angle or the phase shift is at 90 degrees, and that's actually not the case. So if I put it in factored format, I'm going to pull the 2 out to the front. Now it says y equals sine, and then 2 parenthesis theta minus 45. I see that the period is 2, so it's going twice as fast. So the period rotation is 180 degrees. And then inside the parenthesis, I see minus 45. So that would actually tell me that the phase angle would be 45 degrees. So always make sure that you're putting them in factored format, and I'll show you the equations that we'll be following here as we go to look at our examples at the end of our lesson. So when we go to write that argument, there's 2 things that you're going to have to know. You have to know the period, that's the rotation of the graph. Is it still 360? Is it a new rotation? And you have to determine the phase angle as well. Let's review a couple things about the period. How did we come up with that number? And I kind of went over this a little bit already. So the coefficient of the argument, the number that you're going to put in front of your parenthesis. Well, what is the normal rotation for our sine and our cosine graphs? It's 360 degrees. Now, we're also going to see in a second what was the rotation in radian. That was going to be 2 pi, because pi is 180 degrees. So 2 times 180 is the same thing as 360. So in order to find your coefficient, you're either going to do 360 divided by the period if you have degrees, or 2 pi divided by the period if your equation is given to you or your graph is given to you in radian format. The period is where do you see the same thing happening again on your graph, and we'll look at that more carefully when we go to look at our 2 pictures at the end. Now, that's the one thing that you want to pick out when you go to write our equations. The second thing that you're going to have to pick out is the phase angle. The phase angle is what shifted the graph either to the right or to the left. And it's going to matter whether we're doing a sine question or whether we're doing a cosine question. Well, what did we ask ourselves to look for the phase angle for the sine function? We were looking for the point closest to the origin where the graph headed up through the center line. Remember, the graph had to head up because our equations always had plus signs when we were doing a phase shift. When was a sine graph positive? Because it headed up through the center line. The same idea for when we're talking about our cosine graph. How do I locate the phase angle for our cosine graph? It was the angle closest to the center where your graph reached its maximum, where it reached the highest hill. Why did it have to reach the highest hill? Because that's when cosine was positive, and all of our equations are going to have a plus sign at the beginning. Let me go ahead and at this point show you what the general format of our equations are going to look like. So make sure you jot these down and we'll look at what do each of these letters stand for. So it always is going to start y equals because you're writing an equation. You're going to say a plus. So that's always a plus that you have at the beginning of the question, because either you're looking for where the graph heads up for sine or where it reached its maximum for cosine. And then you have b. You'll make a decision. Is it a sine or cosine? And actually, we don't have to make that decision. They're going to have to tell us which one we're writing. You have your c, some number in front of the parenthesis, and then theta minus d. Now, one thing I do want to mention about those parentheses, I wrote minus d, but those actually could be plus or minus d inside the parenthesis because we always put the opposite inside of our parenthesis. So let's just go back and make sure that we remember where do each of these pieces go from. What was the first thing that we always wrote down when we were writing equations of our sine and cosine graphs? It was the center line or the dotted line. So that's what your letter A refers to in the question. What was the second piece that we had picked out? It was the amplitude. How far from the center line do I go, either going up or down on the sine or the cosine graph? The letter C is your period change. So you're going to use one of those two formulas that we looked at earlier to determine the coefficient that's in front of your parenthesis. The D is where you're going to put your phase angle that shifts the graph either to the right or to the left in your question. Now, don't forget, I already mentioned this, for that D for the phase angle, because it's going in the parenthesis, you're going to put the opposite inside of our parenthesis. I have two examples that we'll try together. One's going to be a sine graph and one's going to be a cosine graph. So I think it's going to be easier for you to kind of just to look up here at the screen with me instead of trying to copy down these graphs, because they can be a little bit challenging if you're trying to copy it down and listen at the same time here. So if I were to show you this question, now make sure you always read the instructions because they have to tell you what kind of equation are you trying to write. Otherwise, you don't know. So the question says I'm writing the sine equation for the sinusoid, and that just means for the graph that we're looking at here. So our equation starts y equals. What's the first thing I want to pick out for our equation? The center line, and I can see that that's marked as the number 3. From the center line, either going up or down in my graph, is a distance of 4. So I'm going to use 4 as the value of b in our equation. The next thing I need is the c, which is the period. Normal period, this is in degrees. Normal period for sine is 360 degrees. Is that the case that I have in this question? It's not. So how do I determine the period on my question? I want to find two sections on my graph. Let me get my pen up here for you guys. I want to find two sections where I see the same thing happening in my picture. It doesn't matter where it is, just two sections right next to each other where the same thing's happening. Notice right here at negative 225 degrees, and also over here at 315 degrees, I see that the graph is headed up through the center line. Well, those are two locations that are closest to each other where I notice the same thing is happening. What's the distance between negative 225 and positive 315? It is 540 degrees. I would have had the same answer if I would have used this angle over here of negative 360 and also this angle right here of 180 degrees. Those are two locations where I see the bottom of the different graphs that we're looking at here. The distance from negative 360 over to positive 180 is also 540 degrees. So because our question is given to us in degree format, we're going to say 360 divided by 540 and we'll reduce that in our equation. The last thing that I need to pick out for the sine graph is the phase angle or the shift. Now remember, for the sine graph, we're looking for the angle closest to the middle where it heads up through the dotted line. There are two angles on this picture where I see it headed up through the dotted line. One is at negative 225, one is at positive 315. Which one is closer? Negative 225. So here's what my final equation looks like. I see y equals 3, that was our dotted line, plus 4. It's always a plus sign before you put your amplitude into your question. We're writing sine, so that's what I filled in next. The 2 over 3 is our period. Remember we said that the new rotation was 540 degrees. So I did 360 over 540, and I reduced that down to 2 over 3. The first thing inside my parentheses is always going to be theta, because that's the angle that you're shifting from. Where did the sine graph hit closest to the middle on the way up? It was negative 225, so I have positive 225 inside of our parenthesis. Let's go ahead and we're actually going to look at the exact same graph now, except we're going to try to do it as a cosine equation. Again, we got to read the instruction carefully, otherwise I wouldn't know which one do I need to write. So let me go ahead and show you what the equation looks like as we're talking through this question. I'm going to start with y equals. What is the dotted or the center line? It is the number 3. So I started with that in the question once again. The amplitude is 4. That's the distance from 3 to 7 or from 3 to negative 1. Notice it's a plus 4 is always a plus that you have in front of that amplitude. We're doing cosine, so I put cosine down next. The period was the exact same thing as the last question. I find 2 points anywhere that are closest to each other where I see the same thing happening. Those were at negative 225, positive 315, or at 180 and negative 360. The distance between those numbers was 540 degrees. So I did 360 over 540, and that gave me the fraction 2 over 3. Inside of my parenthesis, again, we're starting with our theta. Our key question for cosine is where closest to the middle does it reach its maximum or the highest hill? Well, where I see it reaching the highest hill on the graph is at negative 90, so therefore inside of the graph I have a positive 90 in your question. Now, please make sure that you do look at the lesson plans that I gave you guys that deal with this work here, because I tried to mention a couple of the graphs in the textbook weren't marked clearly as to the center line or what you were going to do. So please make sure that you do read the instructions that I typed on my lesson plans to help you answer your homework questions when it comes to these phase shifts and period changes for our sine and our cosine graph.